I always think that my phone is like, why did a math teacher have to buy me? Okay. So, yeah, this one here. Do I have control? I do have some control. There we go. That's better. Does anyone need, well, it's actually this. Man, I went from such a great overhead to this thing. Sorry, did somebody need this? Okay. Anybody else need this handout? Two people, okay. Keep one for myself. Oh. You need it? You got it? Who else? You should try before you guys like each other. So one side is 7-3. Oh, hopefully everybody got this right. So guys, last time we talked about trig sub, one of my favorite things in the world. I have no idea how you feel about it, and I have a feeling that some of you don't even know yourselves yet because you haven't tried the homework out yet. So like, I don't know how I feel about it yet, Jeff. I'm really hoping it's nothing too crazy. It's actually, all right, I don't think we did all of these up here, did we? These example problems? Let's see how these work. The thing I really want you to understand, because what happens to students very often is they feel like they just have to guess right as to which trig sub to make. But that's kind of silly. The problem is telling you what to use. So I'm trying to show you, now why does it make sense that constant minus trig function squared would be signed? Because constant minus trig function squared is what its identity looks like. Does that make sense? Right? So like, what's tangent look like? Constant plus trig function squared. Constant plus trig function squared. That's why that would be a tangent sub. Yes?
Professor, do you want to point your camera at the projector screen?
Oh, that would help. I wasn't really planning on doing this right now. Thank you. I should employ.
I could sit right there.
You could earn some brownie points. All right. Not that I didn't do much. Okay. I really desperately want you to see how it's nothing about guessing. The form of the problem tells you which trig function to substitute. So this one is trig squared minus constant. Secant is trig squared minus constant. That's why secant makes sense for the substitution. So on this problem right here, I don't think we did any of these. I don't know.
We did A through A and B.
We did A and B?
Yeah.
So we didn't do C. Okay. So just to remind you guys, you might have this written down on here, but this is constant minus trig squared. That's just like this. Right? 1 minus sine squared is a Pythagorean identity, so I want to let x be, in this case, 2 sine theta. And you make it 2 sine theta, so then when you square it, you can factor the 4 out of the way and get the identity to show up. So, yeah, we did this one. This one was exciting. Had a bunch of rad 2s in it. This is the one, yeah. All right, let's take a look at this one. Let's zoom in a little bit. What sucks about this one?
It's not
factored.
Not in the form, yeah. Shit, man. So, let's all remember how to do completing the square. So what we do is we make a little room, move that +8 over. So what I have to add and subtract so that I can make this into a trinomial that's a perfect square. You guys remember how to get that?
16?
No. So it's half of the middle squared.
4.
Half of -4 is -2 squared is 4. So if I add 4, I better subtract 4 at the same time. So overall, I just did nothing. Yay, Jeff. Okay. So this factors like x minus 2 squared. and then I have a plus 4 out there. Now one little, all right, is that all right? You guys see that? So this is one of the like weird problems that don't quite fall into the forms. You have to force it into the form. Okay, maybe. Okay, so there's a couple ways to proceed. What is now kind of sucky about this?
It's on the bottom.
What's on the bottom?
The trig function.
Okay, well that's normal though. That's oh, as opposed to these two, you're right. But it's
And it's trapped.
kind of funny how very often it does end up being on the bottom. Yes.
It's not in a radical form.
Okay, that's fine. Also, to be honest, it doesn't have to be in radical form.
You have an X on the top.
Okay, it's fine. All right. So
But
the problem
that's-
is,
You
it's
don't-
not. Go ahead, sir.
You don't have an easy way to grab the trig function. Cause
Okay.
like, if you were to factor out to get the x squared to get the relevant identity, you would still be left with another x. You know, you would still be left with that latent x.
So here's the problem. If the bottom was x squared plus 4, that'd be fantastic. Doesn't that exactly follow? It just kind of ignoring the square root for a minute. Doesn't that exactly follow this? Sorry. That's here.
Oh, it's not x squared.
Right?
Yeah, that's what I'm saying, it's not
Okay,
x
okay.
squared, cause the
So-
square is on the outside.
Okay. So one thing you could do if you wanted to, there's two ways to kind of do this. Normally we would say let x equal a something, right? In fact, in this case, what would I use? Trig function squared plus constant. What does that relate to? Plus tangent. So normally we say let x equal tangent, you know, like in this case it would be 2 tangent theta. But that's not what I have here. I have x minus 2. So I could say let x minus 2 equal 2 tangent theta. You guys, that's one way to do this. Right? Basically, whatever squared there, you have to replace it with a multiple of a trig function, right? So what's there is x minus 2. So I gotta replace that. What's normally there is x. X squared, x squared, x squared. That kind of brings in its own issues, right? Maybe, because now x is 2 plus 2 tangent theta, right? Okay, so let's see what happens. Is everybody kind of with me? So there's a couple of wonky things. It wasn't in the right form, but I can use completing the square to put it more in the right form, but it's still not perfectly in the right form. I have more than x in there. Shit. So instead of the normal x equals trig, I gotta make x minus 2 equal trig, because that's what's in there. I gotta replace that whole thing. So the square can attack the trig directly. Are you guys? Okay. So one thing to notice about this is not the regular kind of problem. So this is not the thing that's gonna happen every other problem or something, right? It's one of the wonkier ones. Okay, so let's see what happens. I can replace x with 2 plus 2 tangent theta. That's what that is, right? And on the bottom, I'm gonna get 4 tangent squared plus 4. And I haven't done dx yet. Dadgummit, Jeff. What is dx? 2 secant squared theta. 11. So I need to put at the end here, dadgummit, d theta. Alright, let me write this over here. So I'm gonna get 2 plus 2 tangent theta on the top, because that's what x is. That's what x is. 2 plus 2 tangent theta. On the bottom, I'm gonna get 4 tangent squared theta plus 4. And then dx is 2 secant squared theta
D theta.
d theta.
Wait, what?
Okay. X, right? X is 2 plus 2 tangent theta, yes.
Mm-hmm.
Okay, x is 2 plus 2 tangent theta. X minus 2 squared is 4 tangent squared theta.
Mm-hmm.
4 tangent squared theta plus 4. And dx is 2 secant squared theta. 2 secant squared theta, d theta. I just directly substituted for everything.
Oh, that's just the derivative of the top function. Okay.
Derivative of our x, yeah.
Yeah.
Okay. what happens on the bottom? Can't I take a 2/4 out? I can take a 1/2. There's my next puberty, I love it. So you see how I can take a 2/4 out? So on the top I get 1 plus tangent theta, on the bottom I get, what's tangent squared plus 1? Secant squared. And then I have S, oh shoot, what did I just, I keep doing that. Alright, I love it. Alright. And then this is still 2 secant squared. What immediately kind of happens, thankfully?
Secant.
Oh, what's up? So did I miss something?
Isn't it supposed to be 2 secant squared theta or just secant squared theta since you took out the 1/2? You took out 2/4 and then some.
Oh yeah, I should have taken this 2 out at the same time. That would have been smart. So I could take this 2 out and just make this a 1 out front. Is that what you're? I could take this 2 out and make it a 2/2 out front. Is that cool? Because the 1/2 I took was this 2/4, and then I forgot about this constant of 2. Okay, I like it. I like it. I like it. So the secant squares die. So now I have integral 1 plus tangent theta d theta. Oh, there's a plus, there you go, Jeff. And then there's a t. Okay. That was a trip, right? That did not look like it was gonna become this. And does anyone understand why this is so beautifully easy? What's the integral of 1? Here, I'll do that part. Okay, oof. What can it do with integral tangent? Well, tangent is just sine over cosine, and then it's just a u sub away, right?
Oh gosh.
It's just a u sub away. And you can start to memorize these if you want to. If u is cosine, du is negative sine, so I'm going to end up with negative natural log of cosine, which is also natural log of secant. So you can start to memorize like the integral of tangent. You can memorize that if you want to, it's up to you. So this becomes theta, what did I just say? Minus natural log of cosine, might as well make it that. Plus c, and then what do I have to do? I have to
Find theta.
come back up, figure out what theta is. Theta is just the arctangent of x minus 2/2. Is that right? Just solve for theta, no big deal. And how do I figure out cosine theta?
Draw the triangle.
Yeah, and this time we got x minus 2/2 is tangent theta, correct? Right, x minus 2/2 is tangent. Okay, so then I know what tangent is. It's gonna be this side over this side. And to get cosine, I just need to get the hypotenuse. Okay, that's all I'm gonna do. That's it. So it's not gonna happen an awful lot. Yes?
Can you zoom out so I can see the
Yeah. This one's a little bit insane. If somebody reminds me, if you want to, I can write this up a little nicer if you want to. I just don't want to spend a ton of time on this right now. I just want to give you the idea. Because you're not going to see this exact problem again. Yes?
What's that theta minus the last one I did last time?
This year?
Yeah.
Yeah, so that's the integral. So integral of 1 is theta. And the integral of sine theta or cosine theta. But u equal cosine. The u is negative sine. So it'll be negative sine outside. Whenever u is integral is natural log of u. U is cosine, so I get negative natural log of cosine. So again, you could do the whole u sub thing here, but that's what you would get. Okay. I don't want to spend a ton of time on this, but I just wanted to give you a feel for what to do if they say use trig sub on something like this. Because their first inclination should be, that don't look like a trig sub problem. Is that cool? And in your homework, you should have seen things that are like to a 3/2 power or something, right? Not just the square root. So the square root doesn't actually have to be there. Or it could be a 3/2 power or something else, right? Okay, maybe. Something with the square root part to it, or just no root at all. You could use trig sub. Okay. So. I know I didn't really do that, but I just wanted to show you what to at least start that problem with. Now.
So how you got the data,
Sorry?
the value of the data?
The beta?
The
The
theta.
Theta. How did I get to theta?
Yeah.
Oh. Alright. How solve for theta? Is that what you mean? Like, how do I get this? How do I get the value for this? In terms, okay, so I've got my x minus 2 is 2 tangent theta, right? Which means x minus 2 is tangent, yes? which means that theta is the arctangent of this, right? You just have to do the arctangent of both sides. So, yeah, so x minus 2 over 2 is tangent. Therefore, theta equals the arctangent of that. And that's what you would put there. Because your answer has to be, of course, in terms of x. Yeah, good. So that's the nice thing about it. If you have a wild theta, you just go back to your very first trig sub and then just solve for the trig and then do the arc trig, whatever it is. And that's bam. That's nice. You don't have to draw any triangles or do anything. It's kind of nice. Okay. What's up? Okay.
I love it. Great.
So the main thing to realize on that one is get your trig sub down. I really desperately want you guys to get, you can memorize when to do stuff, you can totally memorize it. And I'm desperately trying to get you to realize you don't always have to memorize shit. You can just make the connection. Which identity does this directly relate to? That tells me which trig function to use. It's not a guess, it's not a memorization thing unless you want it to be, right? You can't memorize your way through all of mathematics. My God, nobody's got a brain that big. Okay. Okay, so now I want to kind of see, because many of you might never have done what we're about to do. So I'm going to sort of get into it assuming most of us don't know about this. And if you know about it, fantastic. You're ahead of the game a little bit. So let's do something a little different here. Can you please take a minute and just simplify this? We're going to do some nice Math 90 level shit for a minute. How's that? Let's take a break from 280. Just simplify that. That's all I want you to do right now. And if you're looking at that right now like, how do I, okay, that's, don't tell me. Just start crying. It's two fractions, right? And you know what you need to subtract fractions. So somehow this is going to relate to some problems we're going to do. How we doing out there? LCD, right? I tell you this. Let me show you something real quick. Just don't even write this anywhere. I'm pretty sure nobody out there did this, but I love it if somebody does plus 3, and then that becomes x plus 1. You see what I'm saying? Is everybody cool with the fact that that is shit? Can't do that. You can't add 3 to the top and bottom of a fraction. Of course you can't. 1/4 does not equal 4/7. Right, so you can't add something. Okay, just to get that out. So obviously, what is he missing? He's got x plus 2. What is he missing? He's got. I'm sorry, x minus 2. Oh. What is he missing that he's got? X plus 1. X plus 1. Blue just dying, poor little dude. So what do we got? 2x minus 4 minus x minus 1. Is that cool? Yeah. And then if I just really put it all the way out into this form, I'll get this, right? Yes. Therefore, you should kind of expect that if somebody gives me something in this form, there must be a way to go backwards to break it up into its parts, otherwise known as decompose it, right? If something decomposes, what does it do? Breaks up into its constituent parts. That's why we decided to call it such a thing as fraction decomposition, partial fraction decomposition. So we're going to break a fraction up into its parts. So this is one of the coolest frickin' things. I don't think I'm gonna be alone in that, but we'll see how many of you agree with me. Let me turn this guy off. Okay. If I give you a problem like this. What was it? Yeah. Let's see if I did this correct. What do you guys think the first step would be to try to start to break this thing up?
Factoring.
And real quick, why are we even talking about this in calculus? Because the problem could be this, yes? And if I can break this up into this, these are just natural logs. So that's, holy shit. So if I can do that for any frickin' fraction you give me, I'm gold, right?
Mm-hmm.
Okay, so that's what we're working towards. Yeah, the bottom, I want to see what parts are, because that's gonna, part of it's gonna be one of the fractions, the other part's gonna be the other fraction, yes? So pretty much rely on that, yes, what's up?
4 and 1, negative 1,
Who do what?
negative 4.
Negative 4, I agree,
And 1.
And 1.
plus 1, okay. So, here's the coolest thing in the world. I really want this to make all the sense in the world. It had to have come from some constant over one of them, plus some other constant over the other, right? So this is one of the best things. You're gonna assume the form of the answer. And we're not assuming anything, to be honest. We know exactly what the answer is gonna look like. It's gonna look like something over x minus 4 plus something else over x plus 1. Now I said something else, they could end up being equal, but I have to assume they're not gonna be equal. I have to give room for them to not be equal, so I have to give them different letters. Somebody with me so far? Does that make sense? Given this example, I expect this should be able to go back the other way in that form, and now it becomes a game. Can I figure out what A and B are? And there are some really kick-ass ways to do that. So watch this. How the hell do I proceed? Some of you guys, has anybody ever seen this and kind of knows it pretty well? All right, you guys be quiet. I want the people that haven't really seen this. This is kind of new to you. How many people feel like this is new to them? Anybody want to? Okay, I like how somebody was like, let me look around. Okay, some people are saying. All right. What do you think I could do to proceed? What really sucks the most about this? Why is this not an easy equation with A and B? Because it's got fractions in it, correct? This is an equation, isn't it? I just set up an equation. What's weird is, x is not really my variable. It's not really the letter of interest. A and B are my letters of interest, right? Okay. So how do I solve any equation that's got fractions in it? Variables on the bottom. Don't I try to get rid of them? Don't I try to kill the fractions? Kill the fraction. Okay. So, what can I multiply by to kill all the fractions? What would kill this fraction if I multiply by x minus 4, yes?
Yeah.
What would kill this fraction if I multiply by x plus 1?
Right.
Right? If I multiply by either one by themselves, it won't kill all the fractions. So what kills all of them? The LCD. And the LCD, of course, is this guy by construction. So let me multiply everything by x minus 4, x plus 1. Okay. There are many, many, many shortcuts to this thing too, so it's kind of nice. I'm going to show you just the plain vanilla crap, and then I'm going to try to show you some great little shortcuts and stuff.
68.
Right? No mods. We're going to start with the no mods.
No mod.
No mods. No. I see the fall over there. Anyway, so if I multiply by this, it's just going to kill all the bottoms, right? So I get a at x minus 17. Over here, what happens? Ax plus a. Is that cool? Why do I keep going back to you, blue? I can't quit you, blue. All right. And over here, what do I get? Is everybody with that? Is that hard? No. Is this different? Have you ever kind of done something like this? Not really. But this is new. This is kind of cool. You're getting to the point in math where this kind of thing happens a lot. We know what the answer is going to look like. So we just say the answer is this, and we put a bunch of A's and B's and shit. And then we work with it, and then we eventually go, A's gotta equal this number, and B's gotta equal this number. And that's how we get the answer. Now watch this. This is so freaking cool. This is one of the coolest steps. What's in front of the x on this side? What's in front of the x on that side if you combine stuff? A, be very specific.
A plus B.
A plus B is in front of the x. And what's kind of constant term is that, right? So what must A plus B be? 8. 8. And that's called equating coefficients. What is silly? Of course it's called equating coefficients. It's exactly what the shit we just did. The coefficient of x equated to the coefficient of x. Right, guys?
Wait, what?
A plus B must be 8 if these are equal to each other.
Okay.
The thing in front of the x has to equal the thing in front of the x if those are equal to each other. Have you ever solved an equation kind of like this? No, we haven't, because we've never had an equation kind of like this. What else can you say?
A minus 4B equals
Negative
negative 17.
17. I love it. Now how do you solve that?
Systems of linear equation.
How the hell do you solve that thing?
You could substitute.
You can substitute, sure. A is 4B minus 17, right? I'm sorry, Blue, you're just gonna have to. Right? Add 4B over, and then take this and shove it in the other dude. That didn't come out right. That's not a terrible sign. 4B minus 17 plus B equals 8, right? So glad I got that up. And that's easy, right? 5B equals 25, B is 5, yes? Yes?
Wait.
And now, sorry? So A is definitely 4B minus 17, correct? So whenever I see A, I can replace it with 4B minus 17. I don't plug this back into itself, that's circular logic. I use this in the other thing, right? I guess with it, this is just subsystems of equations. Remember substitution, elimination. Remember, you can even do Gaussian elimination and matrices and stuff if you wanted to. If B is 5, what's A?
3.
Yeah, freaking 3. Don't make a big deal out of it. The more you know, the less you should have to do. There's no work for that shit. Just know what A is 3. So what does that mean? What is this equal to?
3x plus 3 plus.
Yeah, 8x minus 17 over x squared minus 3x minus 4 is equal to 3 over x minus 4 plus 5 over x plus 1. Somebody out there who has never seen this before should feel themselves leveling up a little bit right now. I mean, that's some cool shit. If you've never seen this before, I'm kind of, your pre-calc teacher really should have shown you this, but to be honest, I know less and less pre-calc teachers are teaching this because less and less have time to teach this. Because unfortunately, a lot of shit's gotten really watered down. We have to spend a lot of time getting people back up to just normal speed. So this is one of the first things we cut, which is unfortunate. So don't worry if you've never seen this before, it happens. Okay. Now, is it always going to be this easy?
No.
The answer to that's always no. Is it going to get really a lot harder? No.
You just gotta keep track of everything.
Huh?
You just gotta keep track of everything.
Just got to keep track of it all. In fact, let me show you a shortcut right now on this problem. Yes?
So, at that point in the step, we decided to do like RREF, can we do that in the calculator?
Yeah, totally. Yeah, so if you get to this point, you got to show me the work,
Yeah.
get this, and if you know how to do it, so your augmented matrix, if I say that, does that make sense to everybody? 1, 1, 8, 1, negative 4, negative 17. Of course, it doesn't look like a calculator, but I think it does actually. Doesn't it have a line? You got a calculator, you get the matrix, build it, tell it to RREF,
How do you do
reduced
that?
echelon form. If all of this sounds like gobbledygook, okay, you don't have to. But you should know some matrices. You should know matrices. Okay, I'm not gonna test you right now, don't worry. So yeah, total. You can put that bad boy in there. As long as you show me this, you can throw it in there. That's cool. Let me show you another way to do this real quick. See right here at this step, we didn't even have to go to matrices. In fact, let me go one step before that. Is this cool if I do this? You guys see this? Right? Before I even distributed. Is that cool? What's x?
Variable.
It could be anything it wants to be, correct? So what if x is I don't know, -1. What would this be? If x is -1, what would this be? -25. What happens here? Cancels. What's this? So then what's b? Frickin' 5, wasn't that quick? Can you always do this? No. When can I do it? When these little dudes are linear, when they don't have complex solutions, for example. Right? If this was x squared plus 1, you would have to use I or -I, and both at the same time, it gets weird, right? But if they're little linear dudes, sweet. You just pick x to be that. Look at that shit. Right? And then what else do I do? If x is
0.
4. Well, 0 doesn't mean shit to me.
Oh,
if
yeah.
x is 4, it kills the other dude. Right? So this will be 32 minus 17.
15. Wait.
15.
Yeah, 15.
32 minus 17 equals x plus 1 is 5a.
A
So
equals
a is
3.
3, which is exactly what we got before. Yes. Just quicker. Wasn't that quicker?
That was quicker.
So every time I can do this, I do it. And I won't always be able to do this.
I was gonna say, is when it's linear, aren't you, that's still solving by substitution, you're setting one of them equal to 0 to solve it, aren't you?
I'm not setting one of them equal to 0. I'm actually using the fact that variable can be what it wants to be in this equation to kill a whole. I'm not really setting.
Yeah, that's
Yeah,
what I mean
yeah,
by
yeah.
setting it to
I'm
0,
with you.
you're killing one whole
You're killing a
variable.
term that contains the
Yeah.
other. Yes, beautiful.
Cause that's what you're doing when you're doing substitution, is you're finding a way to replace that
Exactly.
A.
So, every single fractional, rational expression where the bottom can be broken up into linear parts. You with me? So if I had, for example, 4x squared minus 2x plus 5 over, and I factored the bottom and I got this. What would be the first step on the other side?
ABC.
A over this, plus B over this, plus C over that, multiply by this, da ba ba da ba.
Is it a lot harder once you make it a quadratic, or is it like?
Alright, so, you're thinking ahead. Will these always be reducible to linear factors?
Right.
No. So, what happens if they're irreducible? Or what happens if they're, let's do this first. What happens in this case? Let's see. Well, this is gonna get tricky because I'm just gonna make something on the fly, so.
Oh, that goes well.
Here we go. It always goes well.
X squared minus 1.
The answers will most likely not be whole numbers. If they are, it's just something to celebrate.
It'll be fun.
So what if I had this here?
Yeah, it's a journey,
5x
that's what's nice.
minus 1 over, what do you got, Jeff? Oh shit, it's already a problem. Jeff, x squared.
These are definitely hard
minus
problems
6x
to kind of
plus
just
9.
think of.
Okay. Okay, so this is different in a way. How's the bottom factor now? Right? Now, it can't just be, do you see why, I'm just gonna write this, don't write this. Can you see why this cannot possibly be how this works?
Yes.
That is really silly, because it's basically one fraction then. That's just a plus b over x minus 3. How could that ever make this? So what could lead to this? One of these has to be squared. That's the only reason that that would be squared, is if one of the original ones was squared.
Can you explain that train of thought a little bit?
All right, so let's do a concrete example.
Okay.
Okay? Sort of like I started with the concrete example. If you guys were curious about that answer, too bad. I don't know. Let's see. 2 over, it doesn't matter. X plus 1 plus 3 over x plus 1 squared.
Mhm.
Right? How would you do this?
I'd multiply the one on the left by x.
Yeah, what is he? He's the only one missing, so he's missing an x plus 1, right?
Okay, I get you.
So then you get 2x plus 5 over x plus 1 squared.
Okay.
That's the only reason, after combining fractions, the bottom would be squared. If they were both just this, why would you just shed? You would just add them together. Why would the bottom be squared? Yes? Let that make sense. Notice this. Isn't this a linear factor? repeated.
Yep.
This is huge. It's gonna become huge very, very, very soon, all right? Notice that, this is, I know there's a square there, but isn't this just a linear factor repeated? Notice how the top is 1 degree less than the bottom. The bottom is linear, there's a square. It's a repeated linear. So the bottom is linear, the top is a degree below that, constant. So if the bottom was x squared plus 2, the top would have to be a first degree expression. So we're gonna do that one next. Okay. So let's see what happens here, especially because I just made this shit up. This is gonna be exciting. What do I do next?
Multiply, we get the denominators the same.
And then, yeah, just multiply by x minus 3 squared. And, there's shortcuts for doing this too. I mean, this is gonna die. This is gonna pick up another x minus 3, right? So I don't even do this step for myself. Just die. 5x minus 1. This picks up another x minus 3. Can I do my little shortcut trick? Oh, yeah. Can I do the little shortcut trick? Will it work? Yeah. What would you let x equal? 3. So let's see what happens. If x equals 3. All right, let me slow down for a second. We could equate coefficients, or we could do the little thing where I make x something so that one of these two unknowns goes away. The number of unknowns over here is too damn high, right?
Mhm.
So therefore, if I can do something to make one of them disappear, I can solve the other one. It's the only thing left that's unknown, right? So if x is 3, what's this? 14.
Yeah.
This is 0, so
B.
B is 14. Look at that. Yes?
So why do we have an x minus 3 for A but not? Oh, they cancel out. Never mind.
Yeah, there are
That
2
makes
of them.
sense.
They both cancel. Here, one of
Yeah.
them. So the one's left alive.
Okay.
I love it. Right? Okay. Maybe.
So then there's
So then how do I get what A is? Because there's nothing here. I can't control B, can I? But watch this.
you just plug in 14.
Yeah, you could do that. You could put a 14 in for B, right? But what's the only coefficient on the x? A is the only coefficient on the x. So what must A be? A must be 5. Yes? All right, now listen. This was a relatively easy one. Will that kind of thing always happen? No, not necessarily, but it will happen enough. You start to accumulate little tricks and little things you can notice. If you didn't notice shit here, you would just do ax minus 3a plus b. A equals 5, right? Equate coefficients. Negative 3a plus b must equal negative 1. Yes? You can still, it's fine. It wouldn't take that long. That's no problem. Who cares? Yes, maybe. So you can always, if you're not really sure about this x equals something business, you can always just equate coefficients. Distribute this side, get like terms together, set the coefficients equal to each other. Right? That's fine. Nothing wrong with it. You don't have to find a shortcut. So that's insane. All right, that's kind of insane. So that the fact that it came out nice. 5 over x minus 3 plus 14 over x minus 3 squared. That's cool. Okay, that's cool. So, what about if I have something like this? What you got, Chad? Sure, let's go crazy. Oh wait, I can actually be careful here. You can see what that feels like. Sorry? Oh, you're.
I have a question.
Yes.
So if the bottom is x minus 3 squared, why are there 3 x minus 3's? I'm just not exactly understanding how there's 3 of them.
3, where's 3 x
Because
minus
there's, under A, there's x minus 3, and then
Yes.
under B, there's 2 of them.
True.
Squaring them.
Exactly.
So why are there 3 total? I'm a little confused.
There aren't 3 total, because again, if I try to put these together, isn't he the only one missing something? When I just multiply him by x minus 3, so there's
Yeah.
2.
Okay.
They don't both need something. He just needs 1 more x minus 3, so there is
Okay.
just 2.
Okay.
Is that? I think that's what you're asking.
Yeah.
Okay. I like that. Oh, that's right. It'd be nice here. Hold on. I already started the problem out a little bit. Yeah, look at this thing. 7x squared minus.
Wait,
What's up?
well, kind of based on her question. I thought that the bottom was to be like the factors of
Yep.
like the bottom
Sure enough.
part.
Yep. what are the factors of this?
X minus 3 squared.
X minus 3 squared.
So then why do you need A and B then?
Okay, let's see.
Ooh, that's good.
How do I say this? If I just had b over x minus 3 squared, right? Could that ever equal 5x minus 1, considering b is supposed to be a number? No. So it needed, if I made it a, and obviously if I do this, there's no reason that the bottom would ever become squared. If I do this, then again, that's just number plus number equals number, not 5x minus 1, right? So the only way to make the top some linear polynomial thing is if one of them acquires an x minus 3. Then whatever this number is going to multiply by x minus 3. That's how you get an x piece up there. Maybe? Yes?
Say the bottom factor to x minus 3 cubed, would you do a, b, c?
Good.
Or would you
A
do-
over x minus 3 plus b over x minus 3 squared plus c over x minus 3 cubed.
Okay.
So you could just go insane a little bit, right?
Okay.
20th power. No, I'm not gonna. You know, unless you
How high do-
run out of letters. So if it's 28th power, then you've got to start using uppercase, lowercase. I'm not gonna.
Mhm.
But that's what you would do.
Class when you do that.
Huh?
Maybe just go up to 4. or
Some bonus problem. I love it.
Yeah.
Okay.
Yeah.
Look at this thing. Look at this big bad boy here. Look at this.
Yeah.
Painful.
What do you do first?
Split
Factor.
Factor. I love it. Anybody know how to factor that bottom?
No.
Synthetic
Yes.
division.
I like that you said that. We are gonna get there. Just not quite yet. We don't need synthetic on this. How many terms are there?
4.
Okay, what do you do?
Group 'em.
Group 'em.
Yes.
Oh yeah, old school
I know
shit.
how to do this.
Old school shit.
Synthetic
You guys see there's gonna be x squared plus 2?
Yeah.
And there's gonna be an x minus 1 left. You guys see that? Can I just go there? I mean, grouping should be relatively easy, right?
Relatively.
Interesting reaction. Okay.
Shouldn't it be 2?
There should be a
Yeah.
2 somewhere.
X squared.
Oh, where did the
plus
term
two.
plus 2,
come
yeah.
up?
Yeah.
Okay. Because yeah, 2 comes out of your thing. Now, here's the new thing. What's new here? Are they both linear? No,
One's a
this is
quadratic.
definitely
And you can't break it
second
apart.
degree, right? Okay, so what that means is, when I write down the form of what it could have come from, the top is always 1 degree less than the bottom. It's just where it just leaves the door open to all the possibilities of where it could have come from. So I'm gonna have something over x squared plus 2.
Wait, why is it x squared plus 2 and not x minus 1?
Okay, so an x squared comes out of here, right?
Yeah.
And a 2 comes out of there.
Oh,
You're left with the x minus 1. Okay, right.
I feel silly.
Okay. Right, it's gonna be something like this. So, this covers all the possible things that could be up there. And I want this to make sense. Why couldn't the top be this? Why doesn't, I mean, could the top have been that? Sort of, but wouldn't that reduce then? So this is gonna represent all the parts reduced. So there's no way these degrees will ever equal each other. The top will always be 1 degree below what the bottom is. Right? Now be careful, again, like I said earlier, when we have this on the bottom, it's actually linear, just repeated. So that's why the top is constant, which is 1 degree below linear. This one is not a repeated thing. It is truly second degree. So what should the top be? Linear, first degree. Maybe mix.
So the second one will just be b over x?
C.
Or
No, we've already used B.
So c.
Yeah.
So it's just 1 degree less than the denominator.
Exactly.
Like a derivative.
Huh? Oh, nah. Yeah, sort. Nah. Don't breathe it. This has nothing to do. Real quick. A little concrete example. Maybe I should have, well, no. So if I had 3x minus 1 over, I don't know, x squared plus 5 times x plus 1, plus, no, I'm sorry, just that, plus 4 over x plus 1. How would you combine these? You would give this guy
X squared plus 5.
x squared plus 5, and then you give this guy x plus 1, And without doing all the work, you see how you get some x squares and some blah, blah, blah?
And you get a cube on that.
And you get a cubed on the bottom. Yeah. Yes.
What is the plus b do? Like, why can't it just be a x? Cause that makes sense.
Look here, look at the concrete example. Do you agree that this, well, let's see, 3x squared plus 4x squared, 7x squared, minus x plus minus 2x, minus 1 plus 20, so plus 19, all over this, right? All right. These new markers. All right, right, okay. Do you see how if I didn't have that plus b, there's no way for the problem to tell me there should be a minus
Oh,
1 here?
it's like a plus type of thing? Like it's
Yeah, sure. I have to represent everything that can happen. Now, in the work, could this come out to be 0? Yes. That doesn't mean it would always be 0. It just means in that problem, that was 0, didn't it? So I could have made this like this and done all this shit and got something. And if I would have done this problem for this, b would have equaled 0. Because that's what was there. Does that make? So you got to represent the most general thing that could have been there. And then as you do the work, the letters might equal 0. And you didn't know there were 0 until you got there. Okay, maybe. Yes?
So let's say hypothetically for the second part of the equation, it was x squared minus 1, would at the top then be cx plus d?
Well, if it's x squared minus 1, I would factor it more. But like x squared plus 7.
Yeah.
Then it would be cx plus d. Totally. So each part over here, the top is 1 degree less than the bottom. Okay, so as you break things up, whatever that degree ends up being, that tells you for that piece what the top's going to be. So let's see this problem. So let's see if we can do the shortcut here. What will this part pick up? It's going to lose x squared plus 2, so it picks up x minus 1. Is that cool? I don't have to write down this shit, right? I'm going to multiply this. That's going to cancel. It's going to pick this up. Yes?
Yeah.
What about this one?
X squared plus 2.
Clicks up. Sure. It clicks up x squared plus 2. And over here, I'm just going to be left with the top. Arg. My one good marker. How are you doing? Okay. All right. Does anyone have a suggestion? I like that. Just imagine somebody, oh, I got a suggestion.
I can make it.
Does anyone have a constructive suggestion?
X equals 1.
Yeah, let's do that, right? I could do distribute, equate coefficients, make a matrix, or make a system of equations. That's always an option. But my God, if I can make something die, oh, that sounds terrible. It's not a general life lesson, right? Don't, my teacher said. No. So if x equals 1, this will be 7 minus 5 is 2 plus 7 is 9. Is that cool? That part dies, so I just end up with c times 3, so I get 3c. Oh, look at that, Jeff. Oh, this is what I made up.
And then you can plug it back in.
I actually worked it out and made it work nice. C is 3, yes. And you just said something very interesting. Can you do that again?
Yeah.
No.
Do you want to do it? What would you have to do? You have to use complex numbers, yes. Do you want to plug a complex number in? No, you can't?
Nothing.
Okay, thank you. So what we might as well do is, this is actually now more information. Watch what happens. Let me see if you guys are cool with this. 7x squared minus 5x plus 7 equals, shit I don't know. I'm just going to multiply this out. Minus ax plus minus b. And then I'm going to get plus 3x squared plus 6, right? Right? Using c is 3. I know c is 3. So I can just move that shit over here.
Yeah.
Subtract 3x squared. Subtract 6. And now I've got this next, like, equating coefficients is a little easier if I can write in something that approximates English. There we go. What does A have to be? 4. I think I heard it. What does A have to be?
4.
4. Right? A is 4. What does B have to be?
1. Negative 1.
Negative 1. Yeah, and then let's check. This is -1 minus 4 is -5. You can kind of make sure that it gets the other piece. Are you guys with me? Isn't that nice? Yes?
That is pretty
If we already know that C is 3, since A is the only other one that can make an x squared, can we just know that that's 3 or 7 for the x squared?
I'm sorry? One more
So we know
time.
it's 7x squared minus 1x plus 7, we need a 7x squared. Since we know C is already 3, we have 3x squared.
Yeah.
A is the only other thing that can make an
Yeah,
x squared.
sure.
we can-
So you kind of didn't move this over and you just kind of played it off each other, and I moved it over and made this 4. They're both the same, right? The math in both is the same, you just did it in different order. You got 4 also for A, yes? Yes, okay, okay. So we got the answer. What does this equal? It equals 4x plus, or minus 1, 4x minus 1, over x squared plus 2, plus 3 over x minus 1. So if this was an integral, I did have a much better chance to actually do it, yes?
So what if we're given a problem, like on that one, like in the beginning, before it's even factored, what if happens if the numerator and the denominator have the same degree?
Oh, alright, I love it. It's like I planted you out there. If the denominator and the numerator, either the numerator is the same as the denominator degree, or the numerator is higher than the denominator. I sound drunk. Oh my God, this is in there. If that is higher or equal to this, you long divide first.
Okay.
Everybody's favorite, right? Long division of polynomials. Yes? Where are my long division of polynomial lovers out there? Come on.
Oh, you can just use sub the 4x minus 1 over x squared plus 2.
Oh, you're thinking ahead. You're thinking if this was an integral problem.
Which it's going to be.
Sure will.
This is too much like
But
algebra.
that doesn't take care of the minus 1. Oh shit. So, 2 levels here. Get used to partial fraction decomposition. Once you get that down, then the integration, like this would be easy, yes? What's the integral of this?
ln x minus 1.
Yeah, 3 ln of absolute value of x minus 1.
Yeah,
Right? This might be a little bit trickier, but I have faith. Yes.
definitely doable.
Wouldn't this kind of like be used to replace like what was in 7.3 a little bit, or is that different?
Yes, there are almost always going to be, when we go to another section, we learn something new, you can look back and go, oh, I could have done that shit there. And that would have been quicker. So I'll bet you anything, there are plenty of problems earlier that we did different ways that you can actually do this or whatever new thing we learned, right? Definitely, yes.
Would we be able to use this on like 7.3 homework, and would it be counted correct?
It would be counted completely wrong, my God.
Okay.
So if you're still doing 7.3 homework and we learn something down the road, you cannot use that in 7.3. If you're doing 7.3 homework, you are in 7.3.
Okay.
You only know up to 7.3. Does that make sense?
Yeah.
Don't start doing this or right? Okay.
Is this
Yes.
That's 3x squared plus over 11.
Here?
Yeah.
6, because that was C at 3. 3x squared plus 6. Yeah, yeah. Okay. Right, just put a 3 in for C. So, I think that's enough, but I do want to point out on that paper, wherever I put it, there are examples of all the different ones. We didn't quite get to, well, I guess we did everything. Yeah, we did everything. So there's examples of each one. There's an example of what I call the alternate method, where you let x equal a number. So you don't have to make a system of equations. And you won't always be able to do that, but.
Are we gonna do the examples in class, or?
Yeah, next time, guys, we'll have the quiz. We'll do the 2 examples on this page together. And then I want to talk about synthetic division, and then we'll keep going in chapter 7.
The next quiz is on 7.2 and
Yeah. Monday's quiz is 7.2.
okay.
Wednesday's quiz is 7.3.
7.2 is.
Thursday's foul has 40 now.
What is 7.2 again?
Which homework should
Okay.
we caught up to?
That's the one where it was like sine
I would say-
to m minus cosine to n.
And like
minus
Howard
one.
reduction formula.
So guys,
Yeah.
I would say for the homework, right now, you should certainly be about done with 7.3.
Oh. I'll be done by the time I come back.
You should be at least starting on 7.3. Let me say it like that way.
Okay, that is where I'm.
Right? In fact, you should definitely have that 7.3 done by